Thanks everyone for joining. This session is about logging analytics, and I have the pleasure of introducing you to Zubair Ansari and Sriji Das from our product management and development teams to lead you through the presentation. My name is Akshay. I am part of the product marketing team for observability, DevOps, and cloud native. So if you have any questions, you can send it to us via Zoom as the presentation is going on, and we'll address them as we get them. We will also have a dedicated Q&A session at the end of this presentation. So I encourage you to stay around after the presentation completes for Q&A as well. If you have questions that have to be addressed then. So without further ado, Zubair and Sriji, please go ahead.
Sure. Thanks a lot, Akshay. My name is Zubair Ansari, and thanks a lot, folks, for joining our call today. Today, we'll be talking about our new service that we introduced on OCI platform called OCI Logging Analytics. Essentially, on the agenda today is we will talk about logging analytics overview, some of the high-level functionality that we offer. We will deep dive into some of the UI features that we offer for exploration and ML-based analytics. And then we will go into specific use cases and demos. And towards the end, we will have Q&A. All right. So in terms of overall functionality, logging analytics is machine learning-based log analytics platform. It allows you to ingest any log data, any structured, unstructured data in log analytics platform. It lets you discover, search, and analyze and visualize. So while you're analyzing the data, we have machine learning-based grouping or clustering capability. We have machine learning-based link capability, lets you, analyze data in different angles by looking at specific fields. It lets you group them. It lets you kind of pivot on different fields in millions and millions of records. And it also allows you to kind of monitor specific search patterns by converting them into safe searches and create metrics around them. And then with our alarm features, it lets you react to that. Okay. So in terms of able to ingest data, we have open platform. You can get data through any source. You can either get it through APIs, through our agents, through our cloud platform using object storage. We have a slide on that. We'll talk about it. It also, we package out of the box over 250 log sources and parsers. So you can get logs from any of, open sources or any specific devices. And we are able to automatically understand those logs with specific fields and parsers defined. Okay. In terms of how you can ingest log data into our platform, we have 4 specific areas through which you can do that. First and the foremost is we have lightweight agent that you can deploy on any operating systems. So today you can deploy it on any Linux platform. You can deploy it on Windows platform as well. We can automatically get host logs or any log you want to specify by specifying the directories. If you have containerized environment, we also support containerizing the entire agent and deploy it on the nodes of a Kubernetes cluster or something. We also have support for getting logs through streaming and object storage on OCI platform. So if your resources on OCI or any multi-cloud environment support sending logs into object storage, or you want to use our streaming APIs, you can use that as well. Or if your custom app has API-based log capability, you can write scripts to ingest logs and send us through APIs as well. In short future, we'll also support UI-based log ingestion. So if you have log files on your environment, you can pretty much go to our UI and ingest log and analyze them. So essentially, these platform offer you to ingest log from any sources, as you can see here. So if you have logs coming from your DevOps environment or your development environment. For example, if you have Java logs, you have database logs, or you have container logs in a large microservices environment, we allow you to kind of specify a specific entity. So you can componentize your entire development environment or deployment environment and attach log to those, right? And look at log analytics across your entire application. So you can have different tiers of, your application deployment. You can ingest logs for each of these tiers and analyze logs based on these tiers. So we not only let you kind of look at log for a specific system, but also we let you look at logs from holistic system. So if you have your complete e-commerce application, we let you topologize the entire e-commerce application, and you can analyze logs based on that. So you can go log at the highest level, or you can go to a specific mid-tier level, you can go to a database level, or you can go to even below at the storage or network level and use log analytics for those platforms. Okay. In terms of scalability and integration with our OCI platform, if you're using OCI environment today, you can get started with logging analytics immediately. You have the entitlement, you have the users. All you need is to enable IAM policies for log analytics environment, and you're ready to go. You can take advantage of all the role-based access control through compartment for logging analytics. You can specify policies for your dashboard. You can also use all the common APIs that are available for automation. So if you have Terraform scripts available to deploy environment, you can also enable log collections through those by sending logs to object storage. You can do that as well. Also, we utilize OCI monitoring metrics and alarm platform. So once you have alarms coming in your systems, you can use the common dashboard to look at logs, look at alarms and metrics. Essentially, we are completely integrated into OCI platform. Also, in terms of OCI logging integration, if you are sending your logs to OCI logging for your PaaS and SaaS services or your ISS services, we can ingest log through OCI logging as well. In terms of overall, functionality, right? So what logging analytics offer is all the way from ingesting log and analyzing them from end-to-end diagnostics and troubleshooting perspective, right? So we will be able to, once you create dashboard using our logging platform, and you can set baselines, you can discover clusters. You'll be able to see what's abnormal behavior or normal behavior based on the baselining you have done. You can also look at, what are the different components that are affected. If you deployed your application in production environment, you can look at transaction analysis, response analysis. What are the users who are getting affected? You can understand what problems are there based on error categorization, right? Also, you can create alarms. You can look at metrics, right? And also attach them to specific notification, right? So if you have process workflow, you can attach it to a specific notification process using PagerDuty or any other integrations we have, right? In terms of typical workflow, what our customer use logging analytics for. So it lets you analyze logs, it lets you compare logs based on specific baseline. We have clustering, machine learning based clustering capability that lets you kind of tell you what are the specific patterns, what are the outliers, what are the specific issues that we can identify automatically based on the knowledge we have built, right? And also with the link feature, which is machine learning based, we let you correlate, across millions and millions of logs, right? And while you're analyzing and, doing different types of visualization based on our machine learning cluster and link capability, you can convert these specific analysis and visualization views you have created into specific safe searches. That's nothing but dashboard widgets. And you can convert them into a dashboard that you can visualize either on your NOC screens, or if you're a developer, you can give it to your DevOps people and use it for day-to-day analysis of your application deployment. So here are some examples we have. what you can get out of logging analytics out of the box day one, right? So if you're ingesting logs, say from your Java environment or your Node.js environment or your container environment, okay, or your deployment environment, which might consist of some VMs and some storage, you can get all these logs into logging analytics. And you can send logs into a specific compartment. And out of the box, we will let you visualize these logs. And we will show you different field that we have already identified. You can either specify them at the time of parsing these logs using parsers, or you can define it at the time of your visualizing on the fly. Once you have the data, once you have your data palette on which you have different fields, you can apply these fields into your what we call visualization palette, and you can change the way you want to visualize. We offer different types of visualization option in terms of charting, and obviously histogram is there. You can look at pie chart, you can look at bar chart, and all kinds of visualization we have. You can look at your logs over a period of time. You can select based on time picker, right? And all the search results will be available below. So this way you can use this exploration capability in different way to slice and dice your logs that you have ingested, right? As you can see on the top, we have query bar as well. So if you are more on the developer side or developer, and you want to kind of use our query language, you can pretty much write each and every command that we support in our querying on your own. We will be giving some examples of that. Sriji, who's my colleague on the call, he will be giving examples how you can use the query language to analyze your log in different ways. Okay, so going into the next feature. So as I said, we have machine learning based cluster and link capability. So clustering allows you to out of the box, if you have millions and millions of logs coming from different sources, it allows you to instead of looking at each log line by line and looking at millions and logs and searching them, it automatically groups them in clusters, right? So out of the box, we will be able to tell you how many log patterns you have which are similar, right? And also we will identify what are the potential issues in these clusters that we have identified, and that we do based on specific fields. We are automatically able to identify with the rich knowledge base we have built for the sources we support out of the box. And also we will identify the outliers. So what are the clusters that we think are the outliers? And also we can identify what are the trends, right? What are the group that kind of form specific kind of trends. So here is an example of that. Like in this example, we are able to identify 74 clusters, out of which we feel there are 21 potential issues. There are 16 outliers, and these are 36 trends. And this we are able to do it, for a very large set of log records that we ingest from a specific source. Again, we will give you the example of that in our demo today. Right. Now, going to the next feature, what we call link analysis. So what link allows you to do is it allows you to kind of find specific statistical analysis based on specific common attribute that you want to look your logs for. For example, if I'm looking at my VCN log and I want to analyze what are the top protocols on which all my traffic is kind of flowing, what is being shown here on the right hand side. So I can say I want to see my link analysis based on source and destination data and all the top protocols that are flowing between these source and destination. Okay, so instead of looking at 700,000 records, what you see here, you're looking at a chart on which we are plotting, source and destination on which the traffic is flowing and what are the top protocols. So essentially, you are able to analyze 660,000 records into a chart that is easily analyzed by a network administrator or a developer who's looking at the traffic profile of their data flowing between the application and different users who are accessing the application. So here's just an example of how we can quickly pivot the log data into insightful analysis that a user wants to do and then understand, some quick insight into, troubleshooting and diagnostic of their application deployment. All right. And as I said, you can convert all these, analysis views you have created while you are doing exploration into widgets, and you can put these widgets into a dashboard. And these dashboards are, can be viewed by the user who's analyzing the logs, or it could be converted into a dashboard that your administrators or the network administrators or the application administrators or the data administrator, in this case the example shows, can use it on a day-to-day basis, looking at logs from hundreds and hundreds of resources. Okay, so now what we will do is we'll go through specific use cases, and for the interest of our audience and the topic today, we have selected 3 different use cases that would apply to any developer on day-to-day basis. So first one, what we will look at is, if you are a developer developing application, most likely you will use database, and while you are debugging your application, you want to identify whether the problem is in the application side or on the database side. So this particular use case tells you how you can use log analytics to understand deep insights into how the database is behaving for your application, and able to identify any potential issues with database queries that you might have written, and that might cause any problems, right? So log analytics offers out-of-the-box support for Oracle database, right? We have rich understanding of all different types of logs and what these logs contents are, and able to quickly identify and give you insights into how this log can provide out-of-the-box value to the user who's trying to diagnose a specific problem. So there are multiple logs that database spits. There are listener logs, alert log, trace logs, ASM logs, just to example few. So log analytics has understanding of all these logs out of the box. All user has to specify is what is the directory where these logs are, and we will automatically pick them up. And also we have capability to ingest log through SQL. So if you want to get some more additional logs using SQL, we have that capability as well. We also have planned to build out-of-the-box dashboard that would be packaged as part of our service, something to what you see on the right-hand side. But this is just a demo we are showing you. This will be available out of the box as well sooner or later. Okay. So as I said, what we offer for this use case is out of the box understanding of Oracle database, that you can use in your troubleshooting. So we will be able to identify what are the common errors. We understand all the Aura errors that Oracle has published. So out of the box, we'll be able to identify that. If there are specific issues in the audit log, we will be able to identify that as well and highlight that. And we will also have dashboard with all of these special searches we have kind of curated, and safe searches we have built. So dashboards also would be available. Okay. So just to give you a few examples, right? All these different errors we are able to identify out of the box. You'll be able to see that in your different safe searches. Another example is if you are looking at troubleshooting based on error categories, you can look at you can have different queries. Either you use the existing queries that we will have available as part of these knowledge base that we would build, or you can define your own query language based queries for this. Okay. So at this point, I will give it to my colleague Shriji Das, who will do a demo of database log analytics.
I'm Sriji Das, Senior Director for Logging Analytics. In this demo, we will look at how an application developer can use logging analytics to identify the SQL usage patterns. We will use the Oracle database audit logs for this analysis. Logging analytics provides out-of-the-box support for all the database logs. We are exploring over 1 million database audit logs in this view. The records are parsed out automatically and assigned to the fields like the SQL statement field in this example. Logging analytics has a rich query language as shown here. We can also compute additional fields during query time using this language. For example, the audit logs documentation specifies how to interpret the values of the action field. A value of 3 means it's a select statement, or a value of 2 means it's an insert statement. We can use an if-else statement to inspect the action field and create a new access type field. Now we have an access type field that shows us the type of the query. We will start our analysis by checking the type of queries from our application. Analyzing the trend of query types is as simple as dragging and dropping the access type field into the group by area. We can see that most of the queries are select statements. There are very few inserts or updates or deletes. Now, if you want to look at all the select statements from our application, we can simply click on the select legend, and this drills down into a view of all the select statements. This is the record view of all the select statements, but there are over 900,000 records. These are way too many records for us to manually analyze. We can use the cluster machine learning feature to reduce the number of records. This is as simple as switching to the cluster visualization. Cluster analysis examined the records in real time, identified similar patterns, and grouped them together. The 900,000 select statements we saw earlier were reduced to only 344 clusters. The cluster feature is useful when you have a large amount of data and you want to reduce them to fewer patterns for further analysis. This is the SQL pattern that had the largest number of executions. Cluster identified one variable in this pattern and automatically made that a clickable link. This is the table name. Let us click on the table variable to drill down. This shows why cluster marked the table as a variable. There are only 2 SQLs, and they are exactly the same except for 2 different table names. This is unusual since it indicates a schema is being duplicated. But in our case, we had 410 application and its schema, and this finding is expected. If not, this would have been a good hint to normalize our data. Let us look at other features of cluster. The Outliers tab shows which SQLs are run just once. In an application, the same set of SQLs are typically run again and again. So anything appearing only once would be an anomaly. Cluster analysis also clusters the patterns by time. We can use the Trends tab to identify the SQLs that are typically run together. They usually identify functional areas of the application. For example, this is a SQL that has a particular trend, and the trend looks like this. And when you expand, we can see that this was run just once at 9:43 a.m. The system detected this as a unique shape and gave it an ID. Cluster also grouped 4 other SQL patterns that had very similar trends, and we can drill down to those trends. We can see that all these SQLs had the same shape and same trend, even though the SQL text itself is different. And looking at this, we know that this is from a particular functional area of our application. To summarize, we use the query language to dynamically create a new field. Using that field, we could identify the large number of select statements run by our application. We could then reduce the 900,000 select statements to a little over 300 patterns and analyze them for outliers and trends. We were able to look at the SQLs running on our system, but we were not able to identify which SQLs are being run by which areas of our application. We had used an if-else statement earlier to map the action field to the SQL type. Oracle Database Audit Logs has an object field that captures a table or view being accessed. If we know which tables are used by which areas of the application, then we can use another eval statement to map sequels to application areas. Here is an example of an eval statement. This creates a new field called application area if the underlying object matches any of these tables. And the application area will be called data pipeline. If the object does not match any of the tables here, then the application area will have the value other. We can now see the new field application area. I have added few more rules to represent one of our big data processing applications. We can click on a field to view the values for that field. Let's check what values we see for the application area. So this is the new field we added, and we can see these are the distinct values we have for our application area. We can click on the show trend to also view the trend of each application area, and this indicates what is the database access trend for each area of the application. Logging analytics provides various visualizations to explore the data. Let's use a pie chart to look at which areas of our application generate most of the queries. We will use the application area field to group the records. Again, this is as simple as dragging and dropping this field into the group by area. We can see that data pipeline services generate most of the activity in our database. This is because this particular application supports large volume data ingest and uses the database heavily for bookkeeping. What if we also want to see the type of SQLs that are executed by the data pipeline area and other areas? Logging analytics supports grouping by multiple fields. Let us use the tree map to group by the application area and then subgroup by the access type. As we navigate from the pie chart to the tree map, you can see that the selection is carried over. So this is already grouping by the application area. Let us also add the access type to the group by. We can see all of the application areas are read heavy since we mostly see select statements. This tree map region shows the access by data pipeline, and this shows access by our APIs and administration functional area. Data pipeline has the largest area, and within this area, select takes up the most space. This shows while data pipeline area runs insert, update, and delete, as well, most of the calls to the database are for running select statement. Logging analytics supports multiple visualizations. We looked at the records with histogram view, we looked at the pie chart, we looked at tree map. There are other different types of visualizations that you can use to get different kinds of line charts or word clouds or sunburst charts and so on. You can also save all these as widgets and put them into a dashboard. This is an example of a dashboard that we built for our analytics application. Dashboard like this allows you to have visibility into various areas of your SQLs and applications. As the last topic, we will look at another machine learning area of logging analytics called the link analysis. Link allows you to stitch together log events and analyze them for trends or anomalies. In this example, we have used the original database audit logs and linked using the SQL statement field. Over 1 million audit logs contained 1,326 unique SQL statements, represented by rows in this table. For each linked row, we have additional details, like the number of executions, application area, and the type of SQL. We can roll up this information as summary tiles, like what we have here. We want to get a picture of our application areas and their SQL usage over time. We can't manually look through these thousands of rows. We will use the Analyze feature for this. Analyze goes over linked records and creates a multi-dimensional chart. We will give a title and specify which fields go in the x-axis and the y-axis. Analyze reduce the thousands plus records in our table to a few bubbles in this chart. The x-axis shows the time, the y-axis shows the application area. You can see that there are bubbles of different sizes, and that is because we set number of executions to represent the bubble size. So a larger a bubble indicates there are more SQLs being executed. We can also see the bubbles are of different colors because we chose SQL type to represent the color. We can use these legends to view only the specific SQL types. For instance, we can show only inserts and deletes by deselecting select and update. And this tells us that inserts and deletes are done only by these three application areas. And as expected, we are not seeing inserts or deletes from the reporting UI. We can do more complex filtering by turning on the filter options. These are the fields we used as input to analyze. For instance, number of executions is a numerical field, and thus the values are clustered into ranges. SQL type is a string field, so you're seeing all the distinct values for that field. We can select one or more values to interact with the chart. For instance, if we want to know which area had the maximum number of SQL executions, we can select the top value for the number of executions field. This shows that the application area was data pipeline, and all the top SQL executions were selected. If you want to see what kind of SQLs are run by the reporting UI, we can select reporting UI for the application area. Now this shows that the reporting UI runs selects or updates. Now that's a little odd since we don't expect reporting to do any updates. Let's examine this a little bit more. Let us add update also to our filter. This shows all the reporting UI SQLs that are updates. Our table shows all the SQLs. Let us select these bubbles only to show those matching rows. The table now shows only 10 rows, matching the bubbles that we selected. Looking through the SQLs, we see the first set of SQLs are an update in the alerting functionality in reporting, and the second set of SQLs are for cache management. Although an update statement in the reporting UI looked abnormal initially, after looking at the SQLs, we know that these are expected SQLs. Link and cluster are integrated. So if we had a large number of SQLs in our selection, then we could have simply selected them and run through cluster. And this shows us that these were the SQL patterns that are updates and are from the reporting UI area. The link feature made it easy for us to analyze over 1 million audit log records and identify our application behavior. Besides clustering values from our link table, link can also be used to create typical line or area charts. So we can use this to identify the trend of a specific application area or a specific application access to a specific table. All of these are custom charts that can be built using the query language. To conclude, logging analytics provides several ways to analyze and visualize your log records at scale. While we did this analysis using the audit logs, the features and the query language are generic and can be used to analyze any other logs and identify anomalies.
All right, thanks, Reji. So this was the use case, video we talked about. If you're an application developer using database, you can use all of these functionality out of the box for Oracle database or any other database, because this is the generic functionality that is available. You can tweak it based on different fields, different attributes, but it's an open functionality that is available. All right, so next we'll talk about how you can ingest log from your microservices environment. So essentially, this is just kind of providing details about how you can utilize logging analytics and log our management agent to deploy on any Kubernetes cluster environment. You can deploy our containerized agent as a sidecar on every node and ingest log from your containerized environment and that logs can belong to, specific container. It could have logs coming from, your Java code. It could be coming from your, web servers, WebLogic, or any of the, component that you use in your microservices environment, right? You can essentially, using log analytics, topologize your entire microservices environment and use cluster analysis and link analysis to kind of troubleshoot your problem, right? So that's the beauty of using, log analytics for your microservices environment, that you can completely topologize every log that you're ingesting, attach it to a specific entity. You can create hierarchies, right, and use it for debugging of your application. Another examples we'll talk about today is something, we showcase all the time, is your complete application. So an application could be a custom app or a packaged app like EBS or PeopleSoft-based applications, or a custom app. It could be a 3-tier app that you build, a 2-tier app, depending upon what technologies you're using. And you can essentially, once you deploy your application, either in your DevOps environment or production environment, as a developer, you can look at, logs from these environment, and these logs, based on these log analysis, you can create dashboard for your production environment that can be used by your administrators, or you can look at logs to troubleshoot specific problems. So here, what we will showcase is, a complete, e-commerce application, what we call order app. You can look at your overall transaction analysis, error analysis, and also baseline your, entire operation, right? So this is a dashboard that showcases the overall, store operations, where you can, how many visitors that are coming based on logs. That data we will be able to collect and put it in a dashboard widget. How much purchase is happening, how many users are coming to the store, right? And how many purchases are failed purchases. What it means is that either it was too slow and there was specific errors in the processing of the complete transaction. We're able to extract that and view it as a dashboard, right? These are all based on logs, right? So this is, how would we be able to achieve those using logging analytics is by looking at logs across your entire stack. You can use link analysis to specific attributes. Like, for example, you can look at session IDs and IP addresses and find out who are the users, unique users that are coming to your environment, right? And convert that into a specific save searches and able to understand how many users are coming. Similarly, you can use, response time based analysis, right? Looking at, specific field like, response time, content size, product name, and all of that, right? And able to find specific anomalies, as Sriji mentioned, right? You can see here in the link analysis that most of the transactions response times is kind of aggregated on the, less than 5 minutes. So that's your typical transaction response time. And then there are some anomalies where, it's taking way too much, most likely what kind of some issue that you can look into and further diagnose, right? Another analysis is, the overall transaction analysis. If, using link analysis, you can look at the response time and, the session ID and specific action. You can look at the overall transactions. Here also, you're able to identify with the, how much time it is taking, and different colors we are able to identify out of the box. Right? Look at the transaction analysis. And last but not the least, you can also look at the errors that is happening in your overall order processing based on, the specific knowledge content base we have built into the logging analytics to identify, what are the different errors, and able to kind of provide the analysis-based view using link analytics. Okay. So at this point, we conclude our presentation and open up for Q&A. Akshay, back to you.
Yeah, thanks, Zubair. Thanks, Sriji. If you want any additional information, we have on the next slide here some resources that you can take a look at. This includes things like, Zubair, could you go to the next slide, please? Yeah, this includes things like the logging analytics website, the documentation, logging analytics is part of observability and management. So we have provided the overall category page also for you if you want to take a look at some of the other services that are complementary to logging analytics. Thank you, Zubair, Sriji, and Jerry. For those that are listening in and watching this, Zubair's and Sriji's social information is provided here, LinkedIn and Twitter. Please feel free to reach out to us with any other questions that you have. Until next time, we really appreciate you joining us on this webcast. And if you want to look at more webcasts, please go to developer.oracle.com/virtual events. Thank you so much.
Thanks a lot.